Hello everyone, so today we're going to do more exercises when it comes to mathematical modeling. So the first question is about diagram shows a section of suspension bridge carrying a road over water. So where's the bridge? So the bridge is this one over here. So this is my bridge. I'm going to write it here. So this is the bridge and over water. The height of the cables above water level in meters can be modeled by hx equal to this whatever. So above water level, this is the wave, so you can see this is the above water level that they're referring to, and the cable is this one over here. Okay, so now you are able to see what we're talking about. So let's focus on the wording first, and then we can just make sense of it looking at the picture, because it's essential to actually answer the question. So the height of the cables above water level in meters can be modeled by hx. So h is it represents the height at different points, okay? So at this point, so basically the height from the cable to the water, or from the water to the cable, vice versa. So, and where x is the displacement in meters from the center of the bridge. So if my bridge is this one, okay, so the center will be somewhere here. So this is going to be the center. Let's call it C, okay? So this is the center C of the bridge. So we have to interpret the meaning of the constant term 200 in the model. So we can see that this is the constant term, which is the intercept. When does it occur? So normally the intercept occurs when x is equal to 0. So when the displacement, which is the displacement meters from the center of the bridge, is 0, so basically we are at this point here, because we didn't move neither left or right, so it's in our place. It's going to be 0. This equation, hx, or h0 more accurately, is going to become 200 meters. So yeah, that's when it happens. But when we're here, what does that mean? So this is the difference between the cable and water level. We know that the height represents the height between the cable and the water level. But at the same time, what does that mean at this specific point? That is the height of the bridge above water level. So you can see here, this is the height of the bridge, which is the same thing as the cable when we are at the point C. So an interpretation for this is the height of the bridge above the water level is 200 meters. And I hope that made sense. And then we have to use the model to find two values at which the height is 346 meters. So this is a simple quadratic equation that we have to solve. So hx equal 346. We would replace by the initial values that we're given, 3, 4, 6. So to solve this, I'm gonna take 200 to the other side and keep this one here. 2x squared minus 200. So this is 146 over 0.0012. So now I've isolated my x. We know that this is equal to x plus or minus whatever inside of these brackets. 0.0012. Put everything in a calculator and you will get plus or minus 1103.02, but I'm just gonna keep it at 1103 for significant figures. So the value of x can take these two values, which we found because they asked for two values. So we move on to question C, and and we will be using these values because it says given that the towers at each end are 346 meter, use your answer to bar B to calculate the length of the bridge to the nearest meter. So we want to know the length of the bridge, so this length over here. We want to know how much it is. But we're given a clue that the height of the tower, this one, is 346 meter. Okay? And we know that 346 is the same as the displacement of the cable at these like endpoints. So we can make sense that this has a relationship to part B. Okay? And given that, we already found that the displacement from the center to here is 1103, 1103. So we only have to time it by 2 to get the full length of the bridge, you know. So because like we've given like two values because we're like advancing in the positive side, like in the positive line, so it's 1103, but we also got minus 1103 because it's on the other side, and like C is where like we would say it's 0 whatever. So the length of the bridge bridge is 2 times 1103, which is the same thing as saying 2206 meters. And I think we've got another question for today, which is question 2. Manufacturer uses a model to predict the fuel consumption Y miles per gallon for a specific model of car traveling at speed x mph. So in this case, Y it's representing fuel consumption, and x is representing the speed at their respective unit, mile per gallon and mile per hour. And we have it represent like the quadratic equation is representing this kind of relationship. So we use the model to find two speeds at which the car has a fuel consumption of 32.5 mile per gallon. So again, y is the fuel consumption, so we would solve for y equal 32.5, which is, let's say, A. So since y is equal to 32.5, then like it follows that's minus 0.01x squared plus 0.975x plus 16 equal to 32.5. Here we're just replacing y by the formula and we're solving. So I'll move everything to one side so I can get 0 on the other side, and I can use the quadratic formula. So 16 minus 32.5, that's I think minus 16.5. Oh, then like that's equal to 0. Use quadratic formula. So using the quadratic formula, we get x is equal to minus b, in this case 0.975, plus or minus 0.975 b squared, so that's b squared minus 4ac minus 4 0.1 times minus 16.5, and over 2a, which is 2 times minus 0.01. So all I've done here, I applied the quadratic formula that's provided in the textbook and everywhere. So now I've got to compute everything inside the square root. So I think that's 93 over 320 over minus 0.0. Oh, x is either 21.795 or I guess 75.704, you know. I'd like to keep them at three significant figures. So x is the speed, so hence why we found the two speeds they asked us. So the speeds are the speeds that that at which the car has a fuel consumption of 32.5 mile per gallon are 21.8 and 75.7 mile per hour. So we've got to complete this square. So how are we gonna do it? So we gonna factorize by 0.0 minus 0.01, and to fact like just the two terms, these two. And how we gonna find it for the second term? We're gonna divide 0.97975 over minus 0.01, and that eventually what it gives us minus 97.5x. So all I'm doing here is just factorizing by this term over here, and 16 I'm not going to touch it. And how are we going to complete the square? We're going to focus on these two again, and using the formula, 97.5 over 2 would give us 48.75, and the x is gone and the square is completed right now. Minus 48.75 squared plus 16. And now I'm going to expand. So minus 0.01 x minus 48.75 squared plus, because minus times minus is plus, and because this is squared, it wouldn't, the minus will disappear eventually, okay? Times 48.75 squared. And before I add this to 16, I have to compute it in a calculator. But before that, let's write this one first. Minus 0.1x minus 48.75x, as in like squared. And then this one is plus. To four significant figures, it will be 23.77. Normally it gave me 23.765 and something else, but I'm keeping it at four significant figure plus 16. Minus 0.01 x minus 48.75 plus, as in like the sum would be 39.77. So now let's like try to find which is A, which is B. So I'm given a, so if I would rewrite it in this form, A will be here, minus 0.01 x minus 48.75. So perfect. Now it's like in the same form as the question. So it will be easy to find what is A. So A is 39.77, B is 0.01, because if you remember from earlier, there was a minus here, and again, there's a minus here, so C is 48.75. If there was a plus, then C will be minus 48. And I think we've done what we were required to by the question. So rewriting the form, yeah, we've done that. We found the constants A, B, and C. So now using your answer to part B, find the speed at which the car has the greatest fuel efficiency. We said the fuel consumption is Y and the speed is X. So we want to see the maximum Y value or fuel would take, which is the maximum value for Y. And we know that we can find that through the completed square form. So I mean, like, without knowing the values, if I complete the square, then the maximum point will be at C, where C is the speed, and because it represents the X value, and the maximum Y is going to be, which is the maximum fuel efficiency, is going to be A. So I know it to be C and A because that's like the definition that we've been working with like since when we discovered like how to plot the graphs and everything. I've explained that in detail. You can check that out. And so yeah. So C is the speed at which the car has the greatest efficiency, which is 48.75. The speed is 48.75 miles per hour. And if they asked us about like what is the greatest fuel efficiency or the greatest fuel consumption, you would answer by A, which is 39.77 miles per gallon. I'm not sure if that follows in the next question, but let's check it out. Use a model to calculate the fuel consumption of a car traveling at 120 miles per hour. Comment on the validity of using this model for very high speeds. So this question is giving us like the speed, and they want us to find the fuel consumption. So they've given us x, which is 120, and we need to find y. So, let's first find it out, and then we can see what comments we can give. So in this case, this is part D. I've got the equation here. So given x is, I think, which value was it? 120. Given x is 120 squared, 0975 times 120 plus 16. Everything the calculator will get. That will give us a y value of minus 11. So there is something particular about this value that makes this model not valid for very high speeds, because they asked us to comment on the model's validity for such high speeds. It's not valid. Why? Because y is supposed to be a positive value. Since y is negative, or, then the model is not valid for very high speeds. So when you're dealing with mathematical models or solving them in the context, in their context, you have always to refer to the initial conditions. So we assumed at the start, that x is more than 0 and so is y. Okay, so these are the conditions. Because fuel can only be positive, so does the speed, and x represents the speed and y represents the fuel consumption. Anyways, I think this marks the end of the session today. We'll do more of these. I think I've got a couple more coming, so I shall see you in the next one. Bye.